In this video, let's take a look at the difference between conformers versus isomers. This is can be a very confusing point for new students that are just starting to understand how carbons can be connected and looking at these molecules. So let's just start out with the definitions. Isomer. An isomer are two different compounds that have the same molecular formula, so the same number of carbons, hydrogens, and other atoms. But the key here is they have a different connectivity of the atoms. Conversely, conformers, or different conformations, are simply due to bond rotation. And in a couple examples I'm going to do, hopefully this will kind of highlight the differences between them. All right, so let's look at these two molecules. All right, so the top one here has a total of 4 carbons, so this would be C4. So 1, 2, 3, 4. And as we all know in the line angle type drawing, we would have a total of 3 hydrogens here, 2 here, 2 here, and 3 here. So I'd have a total of 10 hydrogens. Now if we do the same for this molecule, looks like I drew that a little high. Let me put that a little lower so we can see that. C4H10. Now if we take a look at this molecule, it also has 4 carbons. 1, 2, 3, and then the 4th is up here. I'd have 3 hydrogens here, 3 hydrogens here, 3 hydrogens here, plus 1 hydrogen here. It also is C4H10. So these two are related as isomers. And again, they have the same molecular formula, so they're both C4H10, but the connectivity is different. Let's look at this top one now and look at how we could draw two different conformations. If I redraw this 4-carbon alkane, this is again the molecule called butane. And just for clarity, let's just name this one. This would be isobutane. Or I could also name it 2-methyl propane. And that's a good rule of thumb. If molecules have a different name but have the same molecular formula, they typically are going to be related as isomers. Now coming back to conformers, let's take a look at our normal straight chain butane. I've drawn it so it's kind of in a sawhorse sort of orientation, but if I were to rotate 180 degrees about the carbon 2,3 bond, I would now have something that looked like that. So I've basically just redrawn the chain, but I've just taken this CH3, carbon number 4, and I've sort of put it in a downward position. Again, I've not changed any of the connectivity. I didn't like take this carbon off and stick it on to carbon 2 or anything like that. I just rotated about that bond. Another way to look at this would be using a 3-dimensional model. Let's draw this using a 3-dimensional orientation. And you definitely should get some practice doing this. So maybe try this out in your notes. So we're going to put our hydrogens in a 3-dimensional representation coming off the carbons. So in that model now, I have all of my hydrogens in sort of the tetrahedral geometry, 109.5 degree bond angle. So let's label our carbons here. If I now do the same thing that I did above, if I rotate 180 degrees, I can redraw this molecule to basically look like this. And what you're going to see now is that the 2 hydrogens that are on carbons 2 and 3 are now going to both be kind of sticking up off the same side here. So let me just quickly erase this part, and we'll just make a little bit more room. So what this now would look like would be this. So my carbon chain now has sort of a bend in it. And my hydrogens, as I drew them in, would look like this. Okay, so that was the result of a bond rotation. Again, I did not disconnect anything and put this methyl group anywhere else. It's just due to bond rotation. So again, the main difference is then between isomer and conformer. Isomers, different connectivity. Conformers, different bond rotations. Let's just do a quick problem that illustrates how you would approach if you had two different compounds and you had to identify whether or not they were isomers or conformers. So let's just do an example. And let's put that there. Okay. So in looking at these two, first thing you want to do, and this is a real good habit to get in when you're approaching a problem like this, have to identify whether they're conformers or isomers. Let's name the two compounds. That's often going to help us decide. If they have the same name, more often than not, they're going to be conformers. If they have different names, they're going to be isomers. So let's go ahead and name these two molecules. Okay, so this is heptane. Okay, it's got 7 carbons, no double bonds or triple bonds, anything like that. So this is just normal straight chain heptane. Let's name this compound. Notice our longest continuous carbon chain only has 6 carbons, has a methyl group coming off carbon 3. So this is 3-methyl. Okay, hexane. So because these are the same molecular formula, they both adhere to C7H. Let's count them up. We got 3, 2, 2, 2, 2, 2. So we've got a total of 5. That's 10 plus 3 is 13, 16. So that's the molecular formula for heptane. If we go through and we count up the number of carbons, we still have 7. And if you count up your total number of hydrogens, it does equal the same, C7H16. Recall that the normal, or the alkanes, always adhere to this general formula, C to the N, H to the 2N plus 2, where N equals the number of carbons. So if you just have any just regular alkane like that, you can always apply this and just quickly get to the molecular formula. So because these are in fact different molecules, they have different IUPAC names, the connectivity of the carbons is different, these would be identified as isomers. In the next example, we'll take a look at one that may be a little tricky, but we'll see that it's actually conformers. All right, in this example, let's take a look at 2 other compounds and see if we can identify whether they're going to be isomers or conformers. Oh, I had one too many carbons. Very good. There we go. Okay, so let's start out like we did before. We're going to name these 2 compounds. I probably want to start numbering at this end to give my substituent or branch the lower number. So this would be 3-ethyl hexane. And the molecular formula of this one, because we have a total now of 8 carbons, this would be C8. Applying our molecular formula rule for alkanes, we just multiply 8 times 2 and then add 2, so we get 18. So that's the molecular formula for that one. This other one, let's take a look at naming this one. This would be 1, 2, 3, 4, 5, 6. And again, a branch coming off of carbon 3, 2 carbons. This also is 3-ethyl hexane. And it also has the same formula, C8H18. So because these 2 molecules have the exact same molecular formula and the same name, that means the connectivity of the carbons is exactly the same. So what we've done is we've drawn the 2 molecules, but we've drawn them in different conformers. They're due to different bond rotations. So if you take a look at this closely, this upper molecule is represented below here. If you were simply to rotate about the carbon 4-5 bond and sort of flip this entire thing down this way, you essentially now would get this same branch system now down over here. So these are related now as conformers, or different conformations. So get a few more practice problems in like this to make sure that you can identify the difference between isomers and conformers, and you should be all set.